All right, to round out Chapter 7, Section 5, we're going to deal with solving equations where we have rational exponents as part of the work. And so our conventional approach is going to tell us that we would need to take our rational exponent, x to the 3/5 equals 8, and we would need to convert that into radical form. That is actually not going to be necessary here, although it does work. If we rewrite that rational exponent as a fifth root of x cubed equals 8, then we can go through the normal approach of taking both sides to the fifth power and then cube rooting both sides. When we take both sides to the fifth power, I'm just going to write it as 8 to the fifth. I don't know what 8 to the fifth is, but I know it's going to be really big. And so we are going to then cube root both sides, and I'll deal with the mess of that here in just a little bit. If I take the cube root of 8 to the fifth, we understand from our 7-4 lesson that I could simply find the cube root of 8 and then take that to the fifth power. The cube root of 8 is doable. That gives us 2. And 2 to the fifth power is also doable. That gives us 32. However, instead of doing all of that work, there is, as you may already be guessing, a faster approach. Whenever we are handling the situation where we had a 3/5 power, the steps that we took are to take it to the 5/3 power. We took it to the fifth power on both sides. We went from here to there by taking both sides to the fifth power, and then we went from here to there by taking the cube root of both sides, the 1/3 power. So the shortcut here would be to not do so much work. Not that the work is bad, and not that it's impossible for us to do, but the goal here is always, let's have new learning. Let's learn what we ought to do that could be more efficient, save our time, and count again here as new learning. If I take both sides, if I take both sides to the 5/3 power, the reciprocal power, what that gives me is x to the first on this left-hand side. X to the 15 over 15 is going to be x to the 1. I can kind of write that out, which is just equal to x. All right? On the right-hand side, however, we understand that this is the cube root of 8 to the fifth, or 2 to the fifth, or 32. So the work can go a whole heck of a lot faster if we apply the new skills that we found from section 4 to solving these equations. Right? I notice that I've got a little bit of sunlight here, a glare, so I'm probably not going to be able to do the bottom exercise, although if I can get it done, I'd like to try. Over here, we are going to, again, follow our order of operations. First, we have to get the quote-unquote radical part, which is what this is. We have to get this radical part by itself, dividing both sides by 2, and then we're going to take both sides to the 3/2 power. All right? It's two steps. It's cubing both sides, and then it's square rooting both sides. The issue there is I want to highlight that when we are square rooting both sides, I want you to think back to chapter 5. If you're taking an even root on both sides of your equation, you've got to put your plus or minus sign, all right? So when I take this side to the 3/2 power, I'm good to go, but when I take this side to the 3/2 power, I need the plus or minus sign, all right? Now, let's take a moment to simplify what's happening on the right-hand side. The square root, the half power there of 25 is going to be 5, and then 5 cubed is 125. If you're confused on why 25 to the 3/2 power is 125, type it in your calculator. All right? 25 to the 3/2 power, it'll give you 125. But now we've got two possible answers here. We've got x is equal to 2 plus or minus 125, which means x is equal to 2 minus 125, and x is equal to 2 plus 125. All right? As always, it is very helpful if we check our answers. It turns out that both of these answers actually work. We have a positive solution and a negative solution because we have the plus and the minus, and both solutions are correct. When I take negative 123 minus 2, I get negative 125. When I take that to the 2/3 power, I get the cube root of 125 is 5, squared is 25, times 2 makes 50. The same thing happens with positive 127. I take the square root of positive 127 minus 2, I get 125. Take the cube root to get 5, square it to get 25, times 2 to get 50. Right? So it works out. Both answers work. We still check our answers. On this bottom part, and again I've got a really bad glare here, so maybe I'll just write this one up at the top. It looks like the question is 2 times x plus 3 to the 3/2 power is equal to 54. So I do have some work to do here again. I need to divide both sides by 2 first. But on both sides, my reciprocal exponent is going to be 2/3. When I take both sides to the 2/3 power, I'm taking an odd root. I'm taking a cube root on both sides, so I don't need to have the plus or minus. Think about what we did in the very first lesson of this new chapter. All right? So I have the cube root of 27 squared. And so x plus 3 is equal to 9. X plus 3 equals 9. I'll write that over here off of the side here. If x plus 3 equals 9, then x equals 6. Does it work? 2 times 6 plus 3 to the 3/2, you could type that in your calculator and it would indeed tell you that that is 54. Right? So sometimes we may want to convert to a radical form, other times we can get past it without. If we're taking an even root on both sides, we have to do the plus or minus with our square root. If we're taking an odd root on both sides, we do not need to worry about plus or minus.